Okay, we're recording. Go ahead and get started, Tony.
All right. Well, good afternoon, everyone. Welcome to machine programming class. Well, my name is Tony. Pretty much everybody knows me. I've been in the company for 16 years, and I have been programming for the last 11 years. My responsibility is make sure all the fab is translated into the programming and delivered to the machines for all three shops in Fremont and LA. Um, Pretty much that's it. So let's start it. The contents is that we're gonna have an overview, what's the CNC machines, the process of the programming, and I'm gonna talk about, a few software that we usually use to program all the parts to the machines, and how do we scheduling um, releases versus, the shop starts. And at the end, I will have a demo. A quick introduction of the CNC machines that we have in Walt and Wolf. Back to probably close to 15 years ago, or actually no, 13 years ago, we have our first machine from Italy called Planet, which is located in our shop B. Then the next machines that we got is Quadra. The first one we have it in shop A. The second one that we have in shop B, and we have two more in Arizona and one in Seattle. The next one is a Diamond. We also have these machines in Shop A and Shop B in Fremont and one in Seattle. This machine is pretty much is the smaller version of the Planet. And the newest machines that we got, which is a Satellite XT, we have it in LA shop. We just got it last year. And this is the newer version of the Planet and does everything just like Planet, but more efficiency and has more tools on it. There's a quick review of the CNC machine that we have. Okay, next is the overview of our programming process. After scheduling the time to program the releases, first the programmer will retrieve the shop work order from the portal to review it. The programmer has to understand what hole, notches, or cuts they need to create in Canvas based on the pre-existing machining to avoid double work. Programmer will also recognize the similarities and difference of the fab ticket and determine if machining can be used for multiple fab tickets. After that, the programmer will use the AutoCAD to assign the machining to allow the TakeUp program to understand there's a machining assigned to. Then next, the programmer will use the TakeUp program to editing the machining, such as adding whole location or some new attachment components. Then they can output the information with the TakeUp program into a text file called USF file. And this USF file just basically is a text. It shows, the location of the hole, the machining's call out, like such as so and so. Then we will use a job program to import the USF file, and we will review the machinings of each mark number. Later on, I will show you how the job program look like. Last, the programmer will export the file to the CNC machines that are assigned to. So this is pretty much, the process that we do at every single releases, not only the entire release, actually to the part. Campus program. What is a campus program? Campus program is a software program that allows the user to virtually create holes, cuts, or notches on a virtual metal extrusion. As you can see the picture over there, the orange color is our extrusions of our, the part that we program. And you can use a blade, you can use a slot to create the notches. And in there, we have a term called LDT. That's how we use it in all the programmer in different branches. but when we speak to somebody else, we call it as a machinings. And there's a two type of machinings. One is called relative machining, and another one is called absolute machining. So what is a relative machining? Relative machining is created with an X and Y guy, or only X, or just a Y guy with the default positions set as a 0. As you can see the picture on the right hand side, I have a different plane call out. The top picture, that one we call it as a Y guy. It goes along the metal. And if you look it closely, there's a little question mark over here. When there's a question mark, means this guy is going to driven by the number that we enter the TakeUp program. Same thing as an X guy right here. There's a little question mark. So that's how we identify, it is a relative machining or not. So for example, what is a relative machining? Could be a whole location for horizontal, some miscellaneous part like sunshade bracket notch or sunshade bracket hole, etc. Absolute LDT. Absolute LDT is a machining that created by a specific plane or location on the workpiece. For example, like chicken head notch is only happen either on the end, on the bottom of the vert, or like bayonet holes always on the top of the vertical. Or certain thing like notches, like the head member notch to clear the vertical, as you can see the lower right corner. Those is only happen at one end or certain location of the part or the workpiece. We just use the guide to help us out to locating the machining. And you can see there's no question mark over here on this Y guy and X guy. So the first that's how we identify their relative or absolute LDT. Okay, next is a job program. A job program is for controlling machining job, including cutting and machining list. It allows import data from external programs such as our TakeUp program. We can also use this program to optimize a cutting list. And printing the cutting list, we can print it like an optimization list like that, and exporting the data to various machinings. So as I mentioned earlier, you can use this one to review part, review all the whole locations and then the notches. And also we can have to do math, and later on I will show you how to do the math on this. Last is a drill program. Drill program is the program that runs on the CNC machine center, which is all the CNC we have. It allows us to execute the LD8 type files, which is generated by campus or job or running a special generate ISO program. This I cannot demo it because this is only happening on the machines, and the office version doesn't have all the capability that the machine version has it. So if you guys would like to see it, please feel free to contact me. I can walk you through on the shops, and then we can show you on this one. So these three program is provided by the Energy company, which is we bought the machine for, and this is one of the outside software that we have so far. Okay, the last piece of puzzle over here is the TakeUp program, which is our in-house program. TakeUp program is store all the data over here after the PE release the fab ticket. All the programmer will use the TakeUp program to export data into a file, into the text file for programming any CNC machines. And here, there's two areas that we have to pay attention as a programmer. One is the die info table, and then second is the saw section area. In the die info table, as you can see the picture, we have all the part number height and width, reading one, phase width, HDM2A, so on and so on. And you can see the descriptions underneath there. What is a reading one? Reading one is a distance from the back of the mullion to the glass pocket. Later on, I will show you an example how we're gonna dimension it. Phase width, HDMA and HDM2, actually it works as a pair to locate the whole location, such as X and Y, where is the top of the whole mullion of the center of the whole glass pocket or the center of the hole. Last of all is a handed part. Handed part means if you checked it, so the mullion will always come from one direction of the whole location unless we have to force it. Okay, all this information I can see, as you can see on the table, is pretty much entered into the portal. Um, uh, Header will upload, the die drawing from the vendor, so we get most of our uh, overall height and width stuff like that already done, complete. And every Monday, I would get a report, and I went in there and start checking the metal, entering the reading one, the phase width, HDM2A and 2. The handle part, we try not to check it until we programming it, because the earlier function, when we check that, we kind of interrupting the program to creating a fab ticket for vertical. So that part we left it till when we check the box during the programming. So here's a couple example, how do we lay out, reading one, HDM2, HDM2A, so on and so on. So as you can see, the reading one is from the glass pocket to the back of the part. And HDM2 and HDM2A work as a pair to locate one whole location. Here's another example to tell you to explain what is a handed part and non-handed part. For me to explain to people, I usually explain, if you look at the handed part, you only have a one daylight opening side only. When you have a non-handed part, which is you could have a daylight opening on the top, on the bottom. If it's a vertical, you can have a left and right, so on and so on. I try not to explain to people that you can have a two gasket or one gasket, because it could be a handed part, but sometimes has a two different gasket on it. So I don't want to confuse anybody. So the good way to understand is handed part with one daylight opening, or say one it faces to the daylight opening, and non-handed part is two daylight opening sides. Okay, saw section. Saw section, we have a different tables area over here. The first one is a part for saw, which is enter the part number for programming. For example, if we're programming vertical, we just enter one vertical part number. We don't enter all the different vertical part number. The reason of doing this is we want to just focus on one part, and the text file is only have one vertical to check and to export to the machines. Create saw hole location is gather the information from the database, which is showing all the attachment components onto different mullion, and also getting some information over here. Yeah. Also, we can only do it once, because every single time when we start editing it, the information for that particular component will store in the database. But this is called manual work. If we created this saw hole, if we click this create saw hole location button twice, it will erase everything that we've manually done. Okay. Edit hole location right here is basically showing all the mark number, length, attached component, and extra or specific machining that we're gonna add on. And you can see the table here, the last 5 buttons over here: planet, quadra, saw, diamond, compact diamond button. This is basically just pushing the text file into those machines, and we're gonna use those text files to the saw program. Okay, this pretty much, all the program and table that we use. So there's a frequent questions come to me from different project managers. They always ask, when do they gonna have up their program? Uh, I always explain to them, whenever there's a program release, 1 week later, or whenever there's a fab ticket release, 1 week later, your program will be scheduled and released to the shop. But in the last couple of years, I couldn't do that. There's too many jobs, too many parts to release it. So we starting another meeting for scheduling with the shop. Every Thursday at 9:30 p.m., uh, myself and shop foreman from shop A, shop B, and our A shop, we will meet up together and we will review the production schedule that on that week to look into, what job is coming next. And we also have another, table or Excel to show, the coming week and the following week, the current week and the coming week, that what the shop is currently running or fabricating. And also I will list out the day that, which day I'm programming it. I try to divide it, equally for 3 shops. Once we agree everything, oh, actually, and also in the in that weekly meeting, we also will share some issues that we run into it, some solution, how can we solve the problems. For example, if the machine goes down, um, the shop require me, or request for um, reprogramming it from one machine to the other machines. Then the other 2 shop will understand it. They will allow me to, move their schedule or push their schedule out a little bit to complete, the movement. So they can so it will allow the other shop to keep function, not just stop there and just wait until the machine is fixed. It will be delaying the project at that time. So after all the meeting is done, there's a daily schedule, which is a whiteboard in my office. You will see there's a little there was a little magnet tab with a different color of the card on it, and I will put it on each day that I'm going to which job I'm going to program, which release I will work on it, and I try to finish everything in that day to release to the shop. Same thing if it's just a re-releasing, there will be a same process over here, except this weekly meeting with the shops. So I hope I'm not going too fast. I don't see we have any questions over
No
here.
questions yet on the Zoom chat.
I hope nobody falling to sleep yet. Okay, so let's do a little demo over here. I made a video, but I will speak on the top of the video right now. Okay, so today, we're gonna make a demo over here. Is we're gonna use one of the new part that we never programmed before. It's W755692 for the Newman West project. What I'm gonna do is, I'm gonna use this. Hold on, let me pause it over here. I saw questions. What is the difference between all CNC machine pros and cons? What's the difference between all the CNC machine pros and cons? I will explain to you. Let me answer this question later after the demo is complete. Okay. So back to this demo right here is, as you can see, the fab ticket. Pretty much we understand the fab ticket over here is the bottom wheel is our final wheel. When we set up this one, we try to set up the campus, the workpiece in the campus is same way that how you see over here. Okay. As you can see over here, we have a different hole location with different horizontal location, location like that. So how are we gonna program it? To make this fab looks different, we're gonna press the little, machining function button over there. And you can see the notch and feature notes over there. It comes up with the X red color bubble.
There's some additional questions. We can probably field these after the demo, Tony.
Okay. So you can see, there's a little red X bubble over there, which means like those notches have never been assigned. So there's no data in the server. We have to create one with time consuming. So I created a couple of them already. So by right clicking the X bubble, it will bring you up to the window. Then you can see right here, the folder was breaking down by system, which is W75 system or any system. And then from there, we will choose our part, which is 5692. And first thing that we're gonna assign today is the top bayonet hole. You just need to click on it and then click open. Once it's assigned, the wet X bubble become a green, which means the data is on the server now. In the future, this is the bottom bayonet hole. So in the future, the PE, start copying, machinings between fab to fab. These machinings over there, or copying notches between fab to fab, this machining is already been assigned. So the next fab that has different fab ticket number, it will also copying in there. So we don't have to keep assigning. So I'm going to demonstrate how to create a chicken head notch at the bottom. So we're going to have a canvas program open over here. I usually have two screens, but I only have one screen this time, so I just have to, stacking up. First, we're gonna choose which machine we're gonna program. Quadra is the one that we're gonna use for example today. And after that, you can see the Quadra buttons. After we click the Quadra button, the Quadra machines is being chose. And then we're gonna select the DXF file. Again, all the parts, is breaking down by system. And then inside there is breaking by the suffix of the part. At this point, it's a 5692 that we're gonna choose it. Most of the part will be orientated correctly. And as you can see over here, you see the little ring over here to holding all the tools. This is the special for the Quadra. The Quadra has 360. The machine can fabricate a 360 of the part. Now you can see I was trying to rotate it, but we want to do the notching on the far right side. So instead of rotating it on the left, we can do rotation on the right by right clicking it and change the rotation position point to the end piece. And you can see, we can rotate it on the far right. And now we can do the notch easily. To beginning with, I usually set up the guide, to do these notches. To set up the guide, you can click the machining tab and you can see there's all different kind of tools, standard machining like hole, rectangular, unslot, etc. Blade, and there's a reference guide over there. What I usually do is I set up the guide first before I start doing any notches. Now, let me show you how to do the, the 7/16 guides. Let me pause over here a little bit. So on both sides, when you're looking at the piece, the web piece over here, the far left side is start with 0. The right hand side is the one that we call max, which means it can be any cut size. We usually just call max. So if this notch over here on the far right side is 100 inches, the program will automatically knows like, hey, let's go which to the 100 inches like that. Okay, so we just kept it as a max. And so we are going to max minus 4.375, which is into the part. And then I'm going to set up another guy called for 2 and 7/16 max. Okay, so I have a two. So right now I'm going to set up another 1/8 guy over here. This 1/8 guy over here is let us to program, the machining beyond the part. And why is 1/8? Because most of our blade is about 0.2 uh, inches width. Why? The width of the, let's say the width of the blade is 0.2 diameter. So the 0.18 is encounter, the separation cut. When we cutting part installing, the separation cut is making the pieces into the correct cut size. So we can counter in there. So what we're gonna do is we always add 1/8 on every single notch at each end. And now I'm gonna lay out the, Y guide for the rest of the notch location. For the Y guide, we have to pick up the positions. As you can see right here, the position is always from the back of the mullion. So we pick the point is the back of the mullion and coming back in to the notches. The first one is a 7/16, and then the second one we chose to program it is 7/16 plus 3/8 over there, which the notch between two notches. The guide between two notches. And I'll show you later, why we're choosing that point. Now we're gonna lay out the big notch for the chicken head. 2 and 5/8, and then another one is 2 and 5/8 plus 5/8, which is 3 1/4. Now, as you can see, the campus program, we kind of have an outline over here how the chicken head notch look like. We have everything that we need. Oh, I was explaining the 1/8 guy over there, I believe. So let's make a slot. We're gonna start with the far back one, which is the 3/16 slot. The dimension that shows a 2 and 7/16, and we add 1/8 over there, so it becomes a 2.5625. And we're gonna pick the right twos because there's a 3/16 slot, so we're gonna choose 0.188, which is 3/16, and then we're gonna click on the guy that we created. First, we're gonna click the X guy, and then we're gonna click the Y guy. As you can see, the spindle is in the weight right now. You can turn or you can rotate the part, or there's a function you can turn off the spindle and the tool holders. Once we turn it off, now we can clearly see the slot where they're located at the intersection point. So we can change our width, which is the in and out right there. We can put the adjustment in there. So 0.188 divided by 2 is 0.94 to move it into the notch. And the X guy over here is 2 and 7/16. We just need to bring it downward. So we enter the number over there is half of the number that we entered before, which is 2.5625 divided by 2. Once we have all this enter, we see the slot in the right location. Now we're gonna change the Z value. The Z value is when the bit how far away the bit's gonna come down and touch and cutting the metal and how it finishes. We try not to go too far up from the part, and then we try not to go too far down to the part because it would taking too much trouble time. We want to take minimum time to complete all the notches. And the releases over here is how far the tools will be away from the part. As you can check a C minus, you see how deep it goes. Make sure the spindle is not hitting on the part at all. And the gold color of the mill bit is the flute that cutting the part. The silver color part is not. So now we have one of the slot complete, and then we're gonna move on to another slot. So next will be the small one, which is the 7/16 slot that we're gonna cut. We're gonna use a 1/4" mill bit on this one. And again, it's a 7/16. So 7/16 plus 1/8, which is equal to 9/16. We're gonna use that. We're gonna pick different tools. We're gonna pick the X and Y guide that we set up for that particular slot. As you can see, the X number was memorizing from the previous number, so we had to change them. And then we just enter the number and make sure all our notches within the guide, that we set up. And the Z axis over here is pretty much just memorizing it from the previous setup. If you have to change it, you will need to change it. Now we're doing the different machining tools right now. We're using the rectangle nut to do the big chicken head notch. You have to set up the width and the length on this one, and this is also angle. And you can see the radius here, we're using 0.124. The reason why is we try to cut it as close as a square corner. We don't want to use a half-inch mill bit over here to create such a big radius, and it will have this it will interrupt the chicken head. It won't sit. If it's a that low notch, it won't sit perfectly. So again, we're gonna see click the guide that we set up, and then we just put the adjustment into it. Same thing, all these things we know is good. So as you can see, the radius over there on the rectangular slot has been, further out to the, edge of the part, so it becomes a square over here. So we don't have to worry about that. Radius may interrupt, the chicken head when the field setting the unit at that time. So now, once we are complete, we can turn on the spindle back, and that's one function called simulated. We can want to simulate it and see there's any corruptions between the tools or the spindle and the workpiece. When the simulation is complete without any error code come out, so which means this machining is good, and then now we can save it. We can put a description over here, and this one is 2 and 7/16 window notch. So we just type it in 2 and 16. We call chicken head notch. We try to minimize the naming over here. And this is a left jam. Why is a left jam? Because it happened on the left side of the unit, so we call it L. Yeah, we made one before, so I just replacing the naming over here. We always have the dimension go first, and then the action or the machining, work after. And then have a notch or hole, and then L is a side. L or R, representing the side of the naming. Again, so we come back here and assign the machinings. You just have to pick the right part and the right machining. Once it's right here, and then open. And it's done. It's complete assigned. So by looking at here, we have all the notches and holes assigned. We don't do anything for the gasket. So pretty much this fab template is complete for programming. All the visual part. And next, we were going to work on the TakeUp program, which is we're going to check on the whole location of the horizontal. So before we looking at anything, we're going to check the die info table and make sure all the data has been inputted in here. Sometimes it's necessary to manually typing any, some information. Yeah, I have this one done before. So everything has been checked as everything has been entered. When we double check this table and everything is good, we can close it, and then now we can really go to export program. So first, we're gonna enter the part number that we're gonna program for here. Example W755692. Click the create whole saw whole location at the really first time, which is I did it already, so that's I'm not gonna do it again over here. It's pretty much just click and ask you, do you want to override all the existing? You say yes, then that's it. Now we hit edit whole location table. We can see all the mark number, length, and part number here and quantities. And the one that we are working on right now, I believe is a SV2-4E. Cut size is 158, 13, 16, and quantity is 4. So we double check everything over here on the TakeUp program. We have the mark number, we have the length, we have the quantities. And when we open the part side, as you can see, this is the attachment component. It could be a horizontal, it could be a hook lug, it could be a sun-shaped bracket, or it could be any special, machining that was created by the PE. Now we just have to make sure, double check all the location are matching over here. Everything is good. Then we're gonna go back to TakeUp program. And we just repeat the same steps, so on and so on. Like I said, this is special components. We make a special machining and assign it over here. These special components cannot be done in the die info table. It has to do it separately. So we're gonna check every single part like this. So now we are ready to export. So you just have to choose the right machine that you're gonna export it to. This time we're gonna do on the quadra, we're gonna click the quadra button. And it's gonna ask you, do you want the output as a optimized part list? Yes, because the quadra is cut per start link, it's not cut per part. So we want the optimized part list matching with the optimization list from the TakeUp program. So we're gonna do that, and as you can see right here, the blade thickness is 0.2. That's how we set it as a standard. There's no extra machining required for the fab ticket number at this one. So we click no on this one, and now you just have to save the text file into the job folder. And it's supposed to be a performance markup, but I'm not gonna paste it. I'm gonna paste it outside over here for the new one, and I'm gonna type out the part, and then I'm gonna save it. These three, machining that didn't get output, which is was representing one of the gasket or some feature notes on the AutoCAD right here that didn't get assigned to. Zach wrote the program and letting me know that how many of these didn't get assigned to, so I have an idea when I exporting it. So I don't have to keep digging, going back and see why they didn't get assigned. So once you hit complete, the text file is being created, and then we can open a job program and we can import it in here. So first we're gonna hit the file and import the folder. You're gonna have to choose the correct project name where you save that text file and bring it in. So you can see the picture is turning upside down because we didn't have the correct machines we didn't choose the correct machine in the job program. So you will see all the error right now. So the machine, the last program that I export was in the satellite LA. So what we have to do, just click through the OK button. And once this error message is gone, now we can click the pull down menu and choose the machine that we want to use for it. At this point, they ask you to delete machining, you just better say no. Otherwise, wiped out everything, become an empty, straight part only. So once you choose the correct machinings, all the whole location will pop out, or all the machining will show on the workpiece over here. You can see the whole location for the horizontal hook lug, notches, access hole, holes for the bayonet, and so on. And you can see the X and Y position over here. This is what the X-Team2, X-Team2A, X3, X3-DIM-A coming out. We will use the VDIM1 to subtract those to subtract all those whole location, or the distance of the part, to give us an X and Y. So right here, from the top of the head member to center hole is 1/2 inches. And from the face to the first center hole is 1 inches. And then we're gonna go back to the job program and look into it. So you can see it's 1/2 inches from the top. And you see a 4 1/4 for the first hole. We will use a VDIM1. For this part, the VDIM1 will be 5 1/4. And our X-Team2A is 1 inch. So it's 5 1/4 minus 1, so it's a 4 1/4. So that's how we're gonna check our machinings and so on. By clicking through each part and compare with the CAD and doing the math, we can make sure all the part is gonna be correct. Or you can see the virtual right here, what went wrong and why it's like that. So once we check everything, we will make an optimization report for the shop. The shop will use this report and compare with the pieces that are coming out of the machine and check it off. Right here. So the first start link will cut the first part as SV2-4E and so on and on like that. And we're gonna print it as a PDF and save it for the shop. Once we're done, we're just exporting it. We are gonna export it matching with the optimized list at this time. So we make sure the optimized list, column's been checked, and we just hit OK, and we're just exporting it and save it in the correct folder and just wait for it to complete. When it's done, it will say transfer is complete. And then your programming is pretty much ready at that point for the shop to run on the machines. And this is a step that's going to be repeating for every single part. Depends on how big the lease is. It could be taking only like 15 minutes, or it could be longer. This is 1.5 to 2 hours per part. And that is all for the demo.
So Tony, do you want to field the few questions that are in the chat list next?
Yes.
So the first one is from Jack. What's the difference between all the CNC machines, the pros and cons?
Okay, so the pros and cons. For Planet and Satellite, both machines can give us close to 95% fabrication matching with the fab ticket. The cons is you cannot fit the part. The machine cannot fab underneath the part. There's a tool, but the tools is running 3 times slower than the regular tools, so we choose not to using it. But there's a there's a tools for it. For Quadra, the pros is 360. You can fabricate the part 360 a lot. The cons is there's a size limit. You cannot have a profile more than 7 3/4 wide and tall to fit in the machines. And the machine cannot fab small miter part because the clamp will not able to clamp it. DMI is a good machine, but it's only 3-axis machine, which is can only fabbing front, top, and back. But between that, you can stop the machines and flip the part. The corners part is you have to pre-cut the cut size and lower the machine, and the machine doesn't do any compound miter cut or any miter cut at all.
Okay, the next one is from Heather. Do we always fabricate male and female verticals with the legs down? And also, do we fabricate the stack joint head and the sill runners upside down?
No, it depends on which machines. You know, we try to orientate the part that can get most of the machining out from the part. So for the quadra, yes, we're gonna have a leg down, because we don't want the daylight opening surface to facing to the clamp or the bed we call, so we won't get scratches. For the quadra, for the DMR and satellite and planet, we can stand up the part, and so we can get 3-sided, fabricated. For the stack joint, it all depends how complicated the part is. But once we set up the orientation, we will not change. Right now, we will have all the glass pocket facing down. This is going to be a new way to fabricating the stack joint because of the miter cut. When there's a miter cut, maybe I can show it to you while I'm trying to explain to you right now. When there's a miter cut, actually the clamp movement is limited. So what happened is it will not allow us to clamp the short piece because there's a boundary around there for the clamp. So the blade will not cut into it. So one good example that I just completed yesterday is Newman. And give me 1 second, guys. And to answer your seal track, yes and no. On the Diamond and Planet, we flip them upside down. We have the exterior facing inside, so the bead doesn't have to reach all the way to the between the chicken legs. On the Quadra, since it's a 360, so we can have the two come up from the bottom. So this is the cut that we created for, or how we orientated the stack joint head, and then we created, the blade like this. So if this piece is small, so for example, if this piece is only 35 inches, it doesn't allow us to clamp because we need at least 12 inches per clamp over here and here. But the machine will give the boundary around 6 inches away from from the blade, diameter. In here, it could be this cut like this. So pretty much, as you can see over here, your first clamp position will be right here somewhere. So it doesn't allow us to clamp that much. And so I don't know, I did answer your question on that over here.
The next one is from Ed. He's asking, does the CNC machine actually come up out of the part between each cut as shown in the simulation? Is there a reason for this? Wouldn't it be more efficient for it to continue through the whole notch?
Actually come out of the part between each cut.
When you're showing the simulation, Tony, it was coming up and then going back, plunging back up and down on your simulation. And I think that's what he's asking. Because when it did the cut on the notches at the sill and you did your demonstration, it pulled it up and then came back over and then dropped it down again to do that smaller notch at the back of the chicken head.
That because if you can see the blue color right here, this is the entire cut that we are assigned to. So we tell the machine that, this is where you're going to start point and your end point is into here. You can see the dark, blue color line, starting point, and then your end point could be inside there somewhere. If I can do the 3D.
So basically,
X-ray.
I think you're saying it's two different cuts, so it's going to cut it as if it's two different cuts, not one.
No,
wacky cut.
yeah, the machine doesn't do the two changes or spinning it. It just show it to you, there's any collision between that particular machining that we create versus the workpiece. Does that make sense?
Well, but in the machining, in the simulation on the vertical, he's right. It literally, the head of the machine came up out of the part and moved over and then did the next part of the same notch.
Yeah, but actually it's two different tools, but the machine, the simulation doesn't show the two different, but that's actually how the machine doing it.
Oh, because it's switching to a different diameter tool.
Yes, but the machine doesn't, the simulation doesn't show it, but actually that's how far the machine, the tool's gonna come up and then just move on to the next one.
Okay, thanks.
That's why we set the releases as a 0.5. We don't want the tools to come out too far, which is, it wastes our time, right? We're wasting machine time on that part.
Right.
The next question is from me. Do all the tools work on all the machines? And then how many total tools are there that are stocked in the shop?
I knew I was gonna ask that question. So every single machine has different tools on it, but there's 6 standard tools that we set up for all the shops over here. Which is, we go by the quarter. The quarter can only hold 6 tools, and we want to keep that 6 tools in every single machines. So sometimes we can copy the machining over, and then we can reuse it, so we don't have to keep changing tools. For quarter, for Planet, Satellite, and DMR, they have a different kind of tools and different kind of blade size. When it comes to the blade notch, none of the machining can be copied. We have to recreate it, and then we have to create it differently due to the machine limitations. Okay, so quarter cannot do any compound miter. Quarters can only do miter cut. For DMR can only do one-way cut, either the horizontal way or the vertical way. Planet and Satellite has a 360 spinning head, which is allow us to do compound miter, that's called 12-axis machines over here. It's allow you to do all kind of notches, but only one thing is you cannot make the spindle or head tilt upward for all these machines.
Okay, the next question is, does CAMplus have free training available? I realize most of the process has been covered here and is available on the wiki, but I'd like to find some more resources.
There's no free training on this one, unfortunately, because every single machine or computer has to install this software. I had to go set it up for everyone, because we have to pointing out to the same two table. Anything that is changed on the shop, it directly affecting the programmer. So we have a set of a standard or SOP in the shop. Whenever they're changing tools, they have to follow the dimension or the manual book that it says what's the height, what is the width. Blade is a different situation, but the maintenance department doing their good job right now is try to maintain the blade difference between blade to blade is no more than 64. So we don't have to reprogram everything. And also we have a Hector Martinez in the shop. If anything that they have to rerun the program or we export the LDA, then he would do it for me. So I don't have to spend my time to redoing it, most of them.
Okay,
To answer your question is no, there's no free one, but we can put one in your computer.
The next question, if the Quadra stopped working for whatever reason, and you want to do the part on another machine, do you have to reprogram and do the whole process again? Or is there any
Yes.
way that the other machine can read it on a file?
No, they are all different machines. We have 3 different type of machines over here. They functioning kind of the same, but they are all different kind of CNC machine. 12-axis versus 6-axis versus 3-axis machines. So if I have a miter like this on this machine, I cannot do the same thing on quarter. And like I told you, the DMI can only do horizontal and vertical. It doesn't do any 90-degree cut. So basically you have to reorientate the part differently and then using different tools to create the notches.
Okay, that's the last of the chat. Any just verbal questions from anyone?
Well, if not, feel free to stop by to my office. Well, after we get back to the office. Yeah, now I'm home.
You don't want us coming to your house?
Not you, Ron.
Damn you.
Yeah, would like to show you guys, the how to programming it. Just feel free to come over. If I'm not that busy, I feel, I would love to show you guys so more people can understand, this area. I'm the last part of the office before everything going to the shop. Like I explained to you, is a PM over here. They understand, what are we releasing? We releasing the entire week, which means, all this part that we program have to reprogram it or we export it again, not reprogramming it. We just have to redo the export portion. And the export portion, sometimes it takes time. Depends on how many pieces, how many machinings that you have it on that week or that package. Sometimes it can only take 5 seconds to 10 seconds. Sometimes it can take hours. So just let you guys know, we are, as a programmer, we are aiming 8 to 12 hours per releases. Of course, we can, since I've been programming for a while, I can pretty much estimate how long it would take the PE to produce 1 week of releases. It will be how long to take me. So for example, it would take them 5 days. It would take me 8 to 12 hours to, program 1 week releases. If it took them 2 weeks to 3 weeks, it would take me maybe 2 to 3 days. So on like that. Any other questions?
Tony, are you seeing a lot of parts coming in now that are already all set up for you? Pretty much the notches are all done. You don't have to do a lot of work unless it's a new part. Since we're reusing the notches and all the holes from past verticals, is that helping you a lot?
If you guys copying it, yes, it will help me a lot. But I still occasionally assigning, same, machinings into the same, notches that, just call out the same notches that you guys created. Usually, if I see that, I would bring it back to, you guys, or bring it to Eric and have Eric talk to you guys. Any other questions? I hope I cover everything that you guys want to know. Apologize over here. I couldn't show you everything because the time consuming over here is more work to do over here. As a programmer to program one release, I just choose the most simple one to demonstrate. Yeah.
All
All right.
Thank you, Tony. Appreciate it.
Thanks, Tony.
Thank you.
Good job. Thanks, Tony.
Thanks, Tony.
Thanks, Tony.
Thank you, guys.
Thanks, Tony.
Thank.
That was very insightful.